Hello, thank you for joining us and welcome to the second CTF Live webinar. Today, we're going to look at a set of digital technologies that are disrupting construction. We'll look at their use at various stages of a project lifecycle from design through to handover. We'll focus on their benefits and include as many examples of use cases as we can so that we can paint a picture of what each technology can do. For a few examples, where their use can be at different points of the project, we'll separate these and look at them at the specific phase. My name is Rob Jones, partner at B2B Connect, and joining me are Craig Garrett, Head of Digital Advancement Academy at Bentley, Javier Bonilla, Head of the Technology Observatory for Construction at Acciona, Paul Mullett, Group Engineering and Technology Director at Robert Bird Group, Prakash Senghani, Director, Head of Digital Delivery at JLL, and finally Wissam Hijazi, Director, VDC Middle East at EllisDon. We want to make this webinar as interactive as possible and encourage questions, and we'll answer these towards the end. If you have a question, use the Q&A icon near the bottom of your screen to submit it. I want to start, though, with a brief look at data. Now, Prakash, data underpins any plans to use digital technologies in construction, and ensuring data is consistent, without bias, clean, it's essential for success. So, like I said, whilst I don't want to spend too much time on data because it's a subject in itself, give us some brief examples of best practice that should be implemented.
Hi, Rob, thanks. Yeah, I think data underpins everything that we're going to be talking about today. And as we become more data rich as an industry, I think we're going to start becoming targets for bad actors to come and start trying to steal some of it or cause disruption. So some of the things I think that we should be talking about as an industry is data security and data sovereignty. I think that's important. Looking at the tools that we're using to store the data is very important. And then creating a culture where people actually use those tools. I think it's pointless coming and doing an analysis of data storage tools and then people then revert to sending them over emails and things like that. So those are some of the things I think that should be considered.
And Craig, I think, as you know, Prakash has outlined some ideas there or details there in terms of what needs to be considered. I think the other thing is that as the construction sector starts to use more data and it becomes more important, that data is also going to become more attractive to cyber criminals.
Absolutely. I mean, data security has been a growing concern for a number of years, really, since we started to migrate a lot of our data storage to the cloud. And now more than ever, especially even in this crisis, when we have distributed teams and people accessing information from all sorts of private networks. But it's interesting actually that in this current crisis, the uptake on cloud-based collaboration platforms has increased. That's what we're seeing. So while early adopters, companies who were using this technology beforehand were probably quite happy with this, quite familiar, quite comfortable. A lot of the new organizations who are picking up these tools, maybe even for the first time, they're very concerned about, just how secure their information is. But apart from the obvious sort of security that the platform has itself, like the Microsofts and their inbuilt security, there's things that we can do ourselves in order to make our data more secure. We can make it time sensitive, for example, so that after a particular date has passed, certain information is no longer accessible, or we can make it that we group our data in work packages so that only certain people can see the information they need to see in order to do their job, rather than see all the information that's available. So there's practical things that we can do to make our information more secure. But what I would say is the secret is that doesn't happen by accident. And unless we build these security measures into our strategic requirements at the outset, you know, it's just not going to happen, you know, accidentally. We need to make sure that we put those into our strategies to begin with, so that we can actually make them happen in our projects.
Okay. Now, moving forwards, I think to look at the technologies, the reason we're here today, we'll start at the beginning. We'll start with parametric and computational design. Paul, this is used in some of the more complex designs, and you think that we should also be looking and considering this for less complex projects, so that its use starts to become more widespread. Give us an overview of what parametric design is. I think that's probably quite an important place to start, but a brief description, and then where it's used and the benefits it can bring.
Sure, thanks, Rob. I mean, parametric design is really just a different way of approaching a problem. So, you know, rather than drawing geometry as points and lines, you know, we define parameters and relationships that define the way the geometry is built. And by doing it this way, we can modify the parameters and the geometry will change automatically. We're then free to operate on these parameters and undertake so-called computational design. So we can explore multiple design options faster and apply algorithms to find optimal solutions. Now, as you say, parametric and computational design have their roots in complex geometry, but its application has really started to spread in the industry. You know, we see it being used, for example, in areas like spatial planning, master planning, and across structural design. I think my thoughts are the real value is realized when we apply this concept to our everyday work and our everyday tasks. So, I mean, for example, in our business, I've seen it used across a real broad range of activities, from, you know, the design of crane ties, which is quite a simple exercise, through to, you know, design of high-rise megaframes. I mean, the range of applications, you know, it's almost endless.
So how do you start to show its value? Because my understanding is that you need to think about things such as the training requirements and the software tools to make this really work well.
Yeah. Yeah, I mean, the CapEx costs are rather surprisingly low. The software required is inexpensive, and it typically works with core tools that we already have, such as Revit. Training can be done quite cheaply using a mix of online learning platforms, and, you know, there is a community that will help with knowledge sharing. The biggest cost is, you know, is accepting that there's an inevitable period of time where staff have to figure out how to apply these tools effectively on their everyday projects. It doesn't happen overnight, but if you can ride that phase out, the momentum can build quite quickly, and the rewards can be quite rapid on a project-by-project basis. And for ourselves, you know, we've approached it at grassroots level as a business, and we've more than recouped our investment in under 1 year. And this isn't applying it on particularly iconic projects, it's really just embedding the tools into our everyday work.
When you talk about everyday, you know, non-iconic, I think maybe could you just give us a couple of examples of where, are there any real life examples, for instance, of less complex projects where it's been used?
Yes, I mean, when you give these tools and you put them into the hands of engineers, they're able to apply them on almost anything. It's almost like in the same way you would pull out a spreadsheet to solve an engineering problem. Nowadays, they're turning to Rhino and Grasshopper or Dynamo. So they're applying it to everything. They're applying it to, as I said, simple activities like the design of crane ties. It's very well suited to the design of trusses, optimizing beams and beam spacing, you know, right the way through to development of concept designs of load paths. An example I mentioned earlier, like high-rise megaframes. So a very, very broad range, but all offering value.
Wissam, I think if we move forward a little bit from parametric design, a technology that clearly holds promise but is not used that much at the moment, certainly at this phase, is the use of augmented reality on site, giving clients the opportunity to see and interact with a visualization of the final build. Now, from descriptions, there certainly seems to be clear benefits to using AR for this type of application. So could you give us a little bit of insight on how you think it's going to start panning out and being used?
Sure, thanks, Rob. So basically, augmented reality, from its name in principle, you are overlaying a specific design or a specific conceptual design based on an existing topo surface or an existing atmosphere. We started to see the usage mainly on two fronts. The first one is mainly on the design development team from a client perspective. So basically at an earlier, way earlier stage of the design, they can oversee how this new design is going to interact with the new surface, with the existing site conditions. Basically, they can make a lot of faster decision making, whether this is the right orientation of the building, what is the right view, how they can maximize the best utilization of the existing landscape using the AR technology. And also we started to see a certain usages on the sales and the marketing department. With those tools, basically, the end user, the customer, you can engage that level of experience with the design. So basically the client can, or the potential buyer can go to the existing site, use the AR tools in order to visualize how this new space is going to interact with this environment. And also the usage here, there's a lot. We can figure out different design options, how the client, how the market is going to interact with those. It helps us to visualize more kind of the what-if scenarios. What happens if we increase the size of the openings? What happens if we change this type of specific finishes? So in this case, the end user can actually visualize this specific type of a design change, assess its impact, and also understand how this will be incorporated with the existing surfaces. This is really where augmented reality will push that level of coordination. Yeah.
And do you see, or when do you see its use starting to become a bit more widespread?
Basically, there's a lot of awareness now, sessions that happening from the digital transformation teams, whether they are separate consultants or the client themselves. They started to see in this competitive environment how they can utilize this technology more in order to attract more customers and use it. Also, from a perspective of something Paul just mentioned, the tool now is kind of cheap to assess. You just do it set up once. Basically, we started to see the majority of the designers are preparing the models in 3D. So this means also the information is available and it can easily incorporate it. It's not rocket science now anymore. You just do a setup once. And the main kind of like setup where people really want to see the added value is to allow the client to start using it, to start testing it, implementation, see what kind of feedback they're receiving from their potential buyers. And obviously, you know, the software itself will provide a lot of added value from that perspective. This is where we're going to see more widespread of this technology.
And Craig, this kind of leads into opportunities around 4D construction. How will a project benefit from employing this type of technology?
Yeah, so 4D, or construction scheduling, as we would refer to, where you're adding this element of time to visualize your project is absolutely, I think it's becoming a critical tool now that pretty much most, maybe not so much consultants, but absolutely contractors are adopting. We're finding that what was a tool that was originally being used, excuse me, for just creating some nice animations that you might even use from a sales point of view, just to look good and show someone how you might build their project. That's now developed into so much more, and it's one of these instances where a technology has been adopted and you start to use it more and more, and you start to collate more of this data that we're all talking about. But then what happens is you find other things to do with this data. You find more and more possibilities to use this, use this tool for. I mean, just for example, it's, again, initially monitoring and reporting the as-built status of your project. We were talking there about augmented reality. That's become a big part of visualizing a 4D construction scheduling, the schedule in your project. We're now using it to control site deliveries and site logistics. And that's very important if you're actually on a site that's very constrained and it doesn't have areas to allow for material storage. you really have to have things just arriving on site at exactly the right time to be installed. So now these products are starting to be used for that. They're starting to be used for health and safety aspects, because you've got all this information, not just about what you're building, but the site around it in general and what's happening in that site over time. You can start to look in health and safety requirements. Where do people need to be? Where does material need to be? And again, that's relevant in our current environment as well. And then another big one is that you can make that information now available in mobile devices on site, and that lets people make decisions quite live in terms of where they are on the site. They can actually review the information. But the big thing I want to highlight, I would say, is that a lot of people think that this is a tool that just magically happens, but you need to have certain things in place really in order to be able to do this kind of work. And there's two key components to this in my mind. The first one is you need that federated, multidisciplinary, coordinated model. And then you need to couple that with your project plan for how you're going to build your project. And there's a big misconception that you just magically take these two elements, put them together, press a button, and hey presto, you have your fantastically constructed schedule. But the reality is that that's not the case. One is you need to make sure that the right data is in both of those items to begin with. And the other one is that we're actually finding that there's almost a new role or a new skill set being created by the people who are now able to manipulate this. So it's a bit about understanding how the model was created in the first place, and it's a lot about understanding how that marries with the project plan to begin with. So it's become quite a skill set in its own. But there's one thing for sure, it's here to stay. And every time I speak to someone or I'm looking at a project where it's involved, I'm always surprised by the new uses that people are coming up with for this technology. So I would say it's absolutely now, I would say it's probably on most tier 1 type contractor sites as well.
Javier, Craig was talking there about usage on site, and as you start to move on site, and an area that you've been looking at, I know, is around construction site automation and remote monitoring, how IoT technology use is growing. So what applications do you think show most potential here, and where can you see these kind of moving in the future? And I think also one of the things, just touching on what Craig was saying there, is also what kind of KPIs are you setting around data?
Okay, well, as you all know, construction projects tend to be now more and more technically complex, but especially contractually complex projects where our guys on site tend to spend way too long on meetings, on compliance, on procedures, and they have less time devoted to actually building, to actually thinking on how to build a project. So our goal is basically to develop or to provide our team on site tools to help them build more efficiently, meaning improving the project controls on site. That means having real-time measurement of the project progress, real-time control of the resources being used, and so on. And to do so, what we need is basically data, as you said. So what we need to consider is that the project site, which is made actually of different work units, like you can have earthworks, you can have a TBM tunnel, you can have conventional tunnel, and so on, where you have lots and lots of equipment on use simultaneously and in different locations, which are all potential data feeders. Many of the modern construction equipment, they already have data capability, they have the capability to provide you with data that you need to collect. And that's the easy part, actually. What we tend to focus is in how to process that data to actually be able to feed to our project team with information that is useful. For example, type of KPIs, thinking on earthworks. Earthworks, what finally you got is a lot of dozers, dumpers, and so on, moving along kilometers of alignment. And what we provide them is automating the mass haul of the soils involved. KPIs related to the performance measurement, for example, of the each and of the equipments being involved for each of the dumpers, measuring the cycles from the time they are loading, waiting time, downtime, transport time, and then the time to get back. Why? Because they have a parameters. You have a project measurement or a project performance ratios that you have considered, and you need to be able to determine real time if you are complying with that, or the other way around, if you are overproducing, and that's great, or if you are doing less. And problem is that when you are so much involved in reporting and in filling out forms and all that, and you need to do that because it's contractually, you are losing time in not being able to measure that. So we just give them the tools to be able to measure that. And we are, for example, doing that in a project in New Zealand, in Puhoi project, where we have the alignment 20 kilometers, monitor all the fleet. It's not the fleet management, but it's the data provided by the fleet management that we can put in use. Other type of parameters that we are measuring, sustainability, performance, being able to measure the footprint of our projects. How finally we are measuring kilometers, we are measuring fuel consumption. So we are able to estimate actually the CO2 emissions that are being produced in our project. And that's actual measure. It's not a figure that we are inventing or estimating, but it's based on the data that we are controlling. Other examples, TBMs. We have different TBMs operating in the world. We had the TBMs in, well, not now because it's completed now in the Route 2020 in Dubai, but also in Quito. TBMs are basically moving underground factories, fully censored. So what we are doing is using all that sensors to provide to our teams developing the project the information that they need. Shift management, operations, maintenance, performance, and so on. That's what we are doing now. Future, well, use all that sensor to also help them predict what it will be happening, so we can optimize maintenance, so we can optimize the parameters based on the ground conditions or on the past performance. So we are now working on today, but we are also working in how they can do better in real time based on the data that they have used the day before, so to say.
Okay, so we're actually going to come back to, I think, some of that in a little while. But before we do, I'm just going to move on to Prakash, because one of the areas that I think it's kind of already here, really, which is the drone use, but it's accelerating now. So are contractors finding unexpected benefits over them, perhaps what they were originally thought of with drones, and how is it changing, projects on site?
No, you're absolutely right. I think drones have been around for a while now. There's a couple of things I think that are coming together now. One is that their cost is coming down, so that they're much more accessible and commercially more viable to use. But also some of the accessories that can be attached to them are also coming down in price. Things like laser scanners and high fidelity cameras and 360 cameras. And I don't think it's just contractors that are utilizing them. I think clients are seeing the value in them themselves and sometimes purchasing it themselves. Project management consultants such as us at JLL, we're finding great value in utilizing drones for things like progress monitoring, right? So flying drones means that we can get photographs more ubiquitously at greater frequency, whereas perhaps previously we might have only done this type of photogrammetry or photography on a monthly basis. We can now do it on a weekly or bi-weekly basis. Some of the sort of unexpected outcomes, I guess, are the fact that we can quickly create meshes of our sites and then use those and compare them against BIM models, and that helps us to sort of monitor progress. It helps us to do a number of things, identify safety risks and things like that. I think the next evolution of this is combining this data with autonomous robots that roam around on the floor, right? So I think that we're going to start seeing things like the Boston Dynamics Spot, the dog, and other robots of that ilk, which will have all sorts of sensors on them, and they'll be constantly driving around site autonomously, taking measurements of progress, of quality, monitoring safety compliance, and things like that.
And I guess also these are, I guess you're kind of having to couple these with other products and software as well. So you mentioned laser scanning, and Wissam, I guess the same question again, really for you around laser scanning. How are you seeing that evolve?
So obviously, following up with what Prakash just explained, drones will help us a lot from the exterior or maybe on infrastructure project. Laser scanning will be the right tool to use it inside the buildings, obviously. Again, they are being available now. They're not that expensive as before, and they provide very high quality level of scanning. The main added values we see, especially from a monitoring perspective, is that all of those 3D laser scanning points, you can overlay them on your BIM construction model. So a lot of added value can be benefited from the QA/QC exercise. So you can figure out the level of compliance of the final executed product versus what has been designed. You can figure out easily the tolerances of error if you're looking at beams or steel beams. And also, all of your MEP connections, a single scan of that information can be shared with multiple different reviewers. And you will have that information as a replica of your existing site conditions versus what was supposed to be planned. And this will go obviously for your as-built monitoring, and we'll discuss a little bit what's the added value on the handover. What also we see, there are certain challenges associated with that. The specific planning of the laser scanning, especially on an ongoing site condition, this is very critical. Obviously on a site condition, there's a lot of obstacles, whether scaffolding or your equipment to be installed. So that timing when that space is available for scanning in order the point cloud to be clear, this is key. And obviously the question will come, is it beneficial to scan every single corner in the building? The answer is no. Mainly we start to see this, especially here projects in the UAE, we have a lot of complicated designs, complicated geometry, and this is where the real added value is going to come out of those laser scanning points.
Is it also going to help you on sustainability in terms of reducing waste?
Well, as long as you are figuring out what has been installed versus what should have been on site, and figuring out if there is a certain extension of an installed component, a specific extra work has been done on site, that replica scan will provide you with that level of information. Also keep in mind the technology now is available to do something called a scan to BIM. So it can convert those quantities which have been executed versus the original quantities which should have been procured for the project. And that variances will go in how much waste contractor X has deployed. Is it plus, is it minus, stuff like that.
Javier, you talked about collecting on-site data a few minutes ago. One of the areas that this is leading towards, and again, it's a subject that we're going to look into in more detail a little later, but one of the things it's starting to lead into is the use at a much earlier phase of digital twins. How are you trying to promote that? What are the real benefits of a digital twin usage starting this early?
Okay, I would start with what is the definition for digital twin, which is, and I will take that quoted, is a real-time digital representation of the building or the infrastructure. So basically we have now in our projects BIM model, and a coordinated model that comes from the design phase all along the construction stage and is finally deployed to our client or to ourselves if we are later on operating the infrastructure. So fact is we are collecting data from the project as it is going, and we have a BIM model of that project during the construction stage. So next step comes together is embed the data that we are collecting into the BIM model. So what we are basically doing is trying to automate certain synchronization of the BIM model using the real-time data that we are actually capturing and processing from the site. For example, working on the automation of the as design or as build model, the update of the planning or the scheduling, using this automating progress for monitoring, for example, using image processing, or cameras using image processing for inspection of the constructed elements, for the early warning or possible failures like a crack or something happening to the structural element that you have just built. Of course, that would be included image processing for the quality and so on, automated planning, improve decision making in general is the obvious word that could be helped. So you don't have just the building that needs to be updated in the office, which is great, but what you are actually incorporating into that model is everything that is happening and that is being monitored. So you have all the mass hall updated, you have all the task on plan, you have all track changes inside the model, and that's being updated simultaneously and synchronized between reality and the digital world.
And Prakash, I guess some of this is leading towards areas such as machine learning and AI. It's creating a lot of interest. What are the kind of practical benefits you can expect here?
So I think Javier just referred to a few of these, right? So image classification and image recognition for things like maintenance and cracks. That's a subset of artificial intelligence, which is known as machine learning. So I guess the definition of machine learning is it's the use of algorithms which get better over time, the more information that you feed them, and they have a big link to things like digital twins. Some of the sort of other practical examples are, I guess, spam filters, right? Our emails at the moment, and they filter out the spam emails based on historical data, and that's one of the key things. Is that in order for machine learning algorithms to be useful and to be accurate, they need to be fed with a lot of very well structured information and data, and we alluded to this at the beginning of this conversation. And over time, as more information is fed in, when or information or the outputs are corrected, it gets better and better. I think that some of the other sort of uses that I've seen and practical uses that I've seen is its use in conversational interfaces. So things like chatbots. We're working at piloting a chatbot for safety, which changes the way that you interact with traditional sort of management systems. Then looking at semantic analysis, analyzing all of the conversations that are happening on a project or that are flowing through a document management system, for example, and then predicting when one might turn into a claim situation or where there might be a particular issue that needs to be resolved. I think all of these things put together are starting to do the analysis on our behalf, and then presenting the sort of results of this analysis to us in a much shorter time span, which means that then we can make decisions much quicker and much more informed decisions. The other thing I think, as well as looking at sort of the image recognition for fault finding or issues with maintenance, I think the image recognition for monitoring progress. So I've seen examples of photographs being processed and it recognizing whether something's been installed or not, comparing that to a schedule, looking at the date of the photograph, comparing that to a schedule, and then realizing whether we're in a delay situation or there's an issue with progress there. And again, that same sort of technology or that same sort of functionality can be used for spotting health and safety issues, right? People are not wearing their PPE, or that there's a handrail missing, and all of this now can be automated. I think, and also when we talk about machine learning, people tend to get a bit worried, saying that it's going to replace humans. I think that is actually going to augment what we're doing at the moment and help us make things easier to do, quicker to do, so that we can carry on doing some of the value-added stuff, and some of the sort of repetitive and potentially mundane stuff can be handed over to things like machine learning for automation.
And I saw Paul nodding there. So I guess, you talked about parametric design at the beginning of the webinar, and what are the links here with machine learning, and what are the processes needed to ensure that the statistical data sets are being input?
Yeah, well, I mean, parametric design is actually all about data. We tend to think it's about geometry, but really it's about data. by defining parameters, we're able to develop relationships between data, give it labels, store it, and pass it through our workflows. Yeah, as Prakash has just explained, at the same time, tools like machine learning, they rely on data to establish patterns and relationships. And when presented with a scenario, we're able to use those patterns to predict an outcome. The types of applications on site, Prakash has just explained, is things like image recognition, is one area. But if we're looking in design, for example, we need the computer to understand what the data is it's been given, in effect what it's looking at. So, for example, if we were trying to predict the depth of a beam for a given span and loading, the computer needs to be trained with a data set of beams that contains the parameters of span and depth, along with any other relevant parameters such as loading. So if we don't define those parameters, in both the data that the machine learning algorithms are given to learn on and in the design outputs, then the computer can't define an outcome. So really it all comes back to setting up appropriate relational parameters at the outset.
Okay, so Wissam, as we start to move towards the handover phase, again, this is another area where mixed reality technologies can start to be used. So what's happening? What are you seeing? What are the benefits?
So from a VR and AR perspective, the market is still at an early adoption stage with those, especially at handover phases. We, for example, at EllisDon, we started working with a client on a pilot project where we are implementing VR for snagging and desnagging activities. So basically with the laser technology now, you can not only just acquire an actual geometry of the replica of the final product, but you can have also a high quality pictures augmented on that VR thing. So that now you don't need physically to have multiple visits to the actual site in order to assess the quality of the final finish. So you can just create that virtual link, you can send it to a number of reviewers, even the client can look at it, and all of your snagging issues and addressed items, they can be documented and they can be managed through this virtual reality tool. And obviously, when the desnagging exercise is done, you can just do another round of detailed scanning for the rooms, and then this will be part of your handover level of quality. As I mentioned, that the tool now are available. The technology is able now to get you this in a very cheap type of approach. You don't need extensive training. A single unit or 2 units with a developer, that would be enough to scan the whole area. Also, from an added value perspective, we started to see a reduction of time, or we are expecting to see that reduction of time with a handover exercise. Because of that multiple revision and all of your digital assessment of the issues that need to be fixed before the final handover to the client. So this is from a VR point of view. When we look at augmented reality, I think it's more going to affect the commissioning side of things, especially when you're doing a transition of your assets, of your functional assets to your CMMS platforms. With augmented reality now, you can have a detailed replica of the specific dashboards or the performance KPIs of a specific assets. So that information, which is found in your CMMS platform or any operation platform you can just scan the specific asset unit physically, and then you can see a small dashboard on your augmented reality tool showing you all of the performance KPIs. And this is one type of assessing your commissioning activities, whether this unit is performing well, whether you have all of your checklist assessed, yes or no. Again, technology is available. We're still under the testing stage, but I believe that the VR thing for handover will take more momentum, especially with these days where we have a lot of restriction when it comes to for the physical distancing.
So, and actually, if you're using VR for things like this, then the client doesn't even need to be on site, do they? That can be done remotely.
Exactly. So it's a single technical team. This is where the client role will come in. It's a single investment with a technical team, which they can do the scanning. Scanning now is a little bit fast, so you can do a full room in a matter of 5 to 6 minutes, right? And basically, the scan is intelligent enough to understand the relationship between each laser scan from each room, and it will connect them together using this GPS origin system. So you can actually virtually go through every single room from your end, from where you're living at your office. You can just scroll through the 3D model. In this case, it will be the 3D scan, and then you can figure out all the items, raise an issue, raise an inspection request. But yes, you don't have to physically go to the site. And this is where the added value, where multiple people are doing revisions without physically going to the site.
Okay. Now, again, kind of linked with this, I suppose, Javier, is you've been looking at the use of mixed reality for, I guess, the next bit really, which is the FM and O&M. So what are you looking at there?
Okay, we first started looking to mixed reality into our business, water business, where we are basically designing, building, and operating water treatment plants, desalination, and so on. So what the potential there is, you basically have a movable SCADA with you at all time. The operator, who is physically on site, just using this type of HoloLens or similar type of goggles, they have real-time information of the equipment on site, of the piping, for example. They can have assisted remote assistance on the operations that he needs or she needs to take on site. They have performance operations, so he can just check how it's operating against the target values. He can have information on which exact valve he needs to change or to open or to close, or is basically an assisted on-site help for the operator. So that's been started into the water business, and we started there I think it's 3 years ago now, in some of our desalination plants in Spain. And I think we have also run some tests in plants we are building there in Middle East. But sure, this will come up into the construction stage for the construction business, so more really like the gross construction, the bridges or earthworks and so on, for different advantages. I mean, and it will not be probably only mixed reality, but also a combination of mixed reality and augmented reality or virtual reality. You can think of different applications: training, health and safety, inspection of the built element, assisting you in complex construction procedures. So you are on site and you are virtually looking into the construction process that you need to follow when it's some specific elements or it's a very constrained area. Facilitate certain operations like the topographical survey, the stakeout of the project, where you actually need to be built, looking into that into your mobile, but not more precisely, because you basically have your mobile, you have the connection, you have the GPS, you know exactly where you are. You can determine basically your stakeout area or your working area, and not much quicker and with the precision that is good enough to the standard construction process followed nowadays. I think it's definitely not nowadays, but it's where we are going to be moving in the next years or even months.
So really quite close.
I think so. I mean, step by step. Let's not go crazy, but I think that step by step we will be moving there. It's like BIM. I mean, BIM, if you think of it, we first started working in maybe 2007, and then it was very slow, and then 2010 came, and it was all there, and all projects been requiring. So it's something that you can, maybe 10 years ago, we were looking like this is crazy, and in 2 years, everyone was demanding it. So probably this will follow a similar path, yeah.
Okay. Well, and thank you, Javier, because you've set me up very nicely for where I wanted to move to next, which was actually BIM O&M. So Craig, BIM, as Javier has just said, it's really taken off, and we haven't even really spoken about it in other parts of the project, a project lifecycle particularly. However, when you get to the O&M side of things, when you start to think about, and actually maybe even broader asset management, where is it when you get to that point? How is it being used, and how do you see it evolving?
So big topic. And we really need to start to have a bit of a different mindset, really, to understand this, because where we are currently, there's a huge gap. And I spoke on this before, and I actually called the presentation "Mind the Gap," because there's a massive disconnect generally in the industry between the design and build phase and the operate and maintain phase. And we desperately, as an industry, need to close that gap. And it's interesting that the capex phase, the design and build phase, is only really the preparation for what comes next, which is the operate or occupancy part of a project. And when you think the design and build lasts maybe, what, 3 to 5 years, and the operate and maintain phase for say a building is 50 to 60, or for a piece of infrastructure, maybe like a road or rail network, is maybe 100 to 150 years, then we need to start to be thinking with that in mind. And that's when you rightly said there, asset management is where we really need to focus. But it's not in everyone's mindset, especially not if your focus as a contractor is the design phase. If it's not in your remit to consider asset management, then you're not going to do it, you know, by you know, just the goodness of your heart. But what we need to do is we need to adopt a more full life cycle view of things. And it's really important actually that clients and owner operators, they're the key, and they actually have the most to gain from this kind of view of their asset. You know, not just looking at the design and build part, but looking at the data and the information that's being collected at the design and construction phase. That, you know, we've been talking here, everyone's been talking about the data that's now inherent in everything that we do. But that's all being collected at the design and build phase. And the question is, what are we actively doing with that collected data to benefit operation and maintenance? And unfortunately, unless you're a very educated client who has that responsibility for your asset once it's built, the answer is we're not doing very much with that information, but we absolutely should be doing more with it. We're working closely with a number of the rail operators because they do get this idea, because they are the people who are not only designing building, but they're operating, maintaining the railway, you know, once it's constructed. So they have an interest in asset management and the data that's coming out of the BIM process in the early stages, because they want to utilize it later on. But the problem is, of course, that in the early stages, when a lot of the concept work for projects has been put in place and a lot of the strategy documents are being created, that there's not always that operation and maintenance input being provided, so that people aren't being told what they need to get out the end of the process when they start it. So it really is an education thing, really, and people to say have a bigger picture, a bigger, more full life cycle view of things.
But why are not people seeing that fuller life cycle? Why do you think there is that disconnect?
Well, again, quite often in a lot of our own construction industry, it can be a different entity who's designing and building an asset from the one who's going to come along later and operate and maintain it. So, you know, why should anybody bother? Is the point. If you're a consultant and you're contracted to deliver a design, or a contractor collected, you know, to deliver the building, if you're not specifically being told you have to worry about what comes next, then you're not going to do it. So you know, you really, that's why I'm saying it's a different mindset. You need to be starting to think, right, what information do I need to operate and maintain my asset, and make sure through the whole project that you have that information provided for you. I attended an interesting session actually by the IWFM, and they said that one of the best projects that they'd ever worked on was where the asset management organization were put in charge of the construction, because of course they understood what they needed to get out of the process, and they made sure that it was delivered, where of course, you know, a lot of the other stakeholders don't necessarily do that.
I want to move on, thank you. I want to move on now to digital twins, which is linked really with what you've just been talking about. And Paul, I sent you an article actually that I'd stumbled across, which talked about parametric design, gate crashing the whole life cycle of a project. And it talked about, again, the link with digital twins. So there are clear benefits on why to use digital twins. And certainly I think in some areas their use is rising, but there don't seem to be that many examples in the Middle East. What should companies be thinking about for successful digital twins, and what are the barriers?
Yeah. Well, again, answering that in the context of parametric design, it comes back to the point before. Parametric design is all about data. So by parametricizing our designs and models, we're able to pass that data through our workflows. And if we effectively collapse that into one entity, I guess that's what you'd call the digital twin. So you're fed with either real life data or hypothetical data. We can then use analytical engines or AI algorithms to offer predictions about future scenarios. I mean, that concept can be applied during design to evaluate performance. We can use it during construction or pre-construction to explore build methodologies and sequences or time cost outcomes. We could use it post-handover to understand operational efficiencies and predict maintenance issues. I think the uptake is low because it's still pretty hard to do. We're sat here as a panel of so-called experts or specialists, but I think the reality is this is quite a tricky thing still to do. It still requires an integrated application of a range of techniques. So I think the first steps that anyone needs to take if they're thinking about developing a digital twin is to ask, well, what am I trying to predict and why? And then focus on creating a digital twin to achieve that specific goal. Don't worry about the label, the badge, digital twin. Just create something that will enable you to make the predictions you want to achieve that goal. So I mean, for us, by example, at RBG, we're particularly interested in the concept of digital twins for construction. So a construction rehearsal, if you like, to try and de-risk the construction process. So at the moment, we're combining complex structural analysis, BIM models, site data, and gaming style visualizations to help us develop construction methodologies, understand them, predict what might happen, and then communicate them. Now, I would perhaps hesitate to call that a digital twin just yet, but it's certainly the direction of travel. So, I'd encourage others to think about what it is they're trying to achieve, what they're trying to predict and why, and then create a workflow or a process that helps them achieve that. And perhaps that will be a digital twin.
Now, as I started asking that question to Paul, I mentioned that there are not many examples in this country, or in this region certainly, of digital twin use. But Prakash, you are kind of the exception to that, in that you're working on a large-scale example of digital twin use in Saudi Arabia, and that's linking many buildings. I think a few are linked so far, and the plan longer term is to link something like 40. So I guess a very simple question: tell us what the project is, its aims, and the benefits it's going to bring.
Yeah, so I think definitely we are an exception, and I think, as Paul mentioned, it's the exception because it is difficult to do. I think one of the reasons that we have been able to undertake this is because, again, going back to something that Craig mentioned, is that we had an informed client, we had a mature client who understood the potential benefits of creating a digital twin of their assets, and luckily they were the ones that are going to be maintaining and operating these assets once they're completed. So I can't obviously talk too much detail about the project. It's still a live, ongoing project, but essentially we were brought in to digitize buildings that were in various states of construction. It was a city that was sort of left halfway through its construction, and then it went on a long pause, and then they wanted to reinvigorate it again. And so the initial driver was to try and get a very good picture of what was existing and what was there. And that sort of developed over time into, now we've got this information, and it's as accurate as it can be. It's probably more accurate than if the project had run its natural course. What else can we do with this information, this 3D information that we created? So initially we laser scanned almost 50 buildings and created very accurate BIM models from these laser scans, and it's stuff that we've alluded to in other parts of this conversation. And then we went on to upgrading these models to include information that will be required for operational purposes. And because the client themselves were going to be the operator, we had access to that expertise from the client side. which is rare, right? So typically on projects, the operator or the people that are going to be managing the asset and operating the asset, they come on much later in the sort of design and construction phase. And so unless you're an expert in what's got to happen in that, it's very difficult for you to embed some of this information into it. And there's obviously nuances for every single project as well, depending on what asset class it is, whether it's a hotel or a mall or a residential building. So what we had was we had the ability to access these requirements and these needs of these experts and start embedding that into the information that we were capturing and the parameters that we were inserting into the BIM models. We were also able to dictate to a certain degree the packages that were going to be associated and used with it. So what we're doing at the moment is we're connecting these BIM models to things like the computer-aided facilities management software, the building management system, and what we want to try and do and get out of the end of it is to visualize when something goes wrong and automate the process of trying to get that fixed. So for example, the building management system, the BMS, might trigger saying that there's a particular room within the building which is not cooling enough. And through the BIM model, because all of the systems are connected, we know which air handling unit is responsible for cooling that room down. And through that, we can raise a ticket in the computer-aided facilities management software to say that there might be a problem with this air handling unit. Somebody please go raise a ticket, say, come on, someone please go and have a look at this. And you can visualize this as well. In the BIM model, you can highlight a different color saying, look, there's something wrong with this room. So these are the types of use cases that we're trying to achieve out of the digital twin. Like you mentioned, we've got a small subset of this larger one, which are operational, and we're going through the sort of the unit testing for these and making sure that all of the data points work and doing and behave the way that they're meant to. But there's been many lessons learned throughout the process, and as you can imagine, there's multiple different interfaces. There's different ways that data is read. There's restrictions on the length of things that you can put into one system which doesn't exist in another system. So there's a whole bunch of obstacles that we need to overcome.
And going to, I mean, it sounds like this is quite a long-term project. And looking more to the future, are you looking at integrating other types of technology that maybe you haven't started or thought about yet?
Yeah. So definitely, we're the next stage of this is to start integrating certain Internet of Things, IoT data. So things like camera feeds, occupancy sensors underneath desks, temperature sensors, installing. And then utilizing these data feeds to start doing things like predictive maintenance, right? So at the moment, things are maintained because the manufacturer gives us a guideline saying that they need to be maintained on a 6-monthly basis or an annual basis, depending on what it is. And that doesn't necessarily mean that that's when it needs to be maintained. It might be that because of a particular situation or a circumstance or where it is in the building, it needs to be maintained more often, or because it hasn't got its use, it doesn't need to be maintained at that frequency. If we can get this information and this data, analyze it, and then we can start predicting when that maintenance needs to be happening, and that makes the whole maintenance process much more efficient.
So this could actually have a real benefit also to not just things like downtime, but also the costs of running a building, because you're not having to replace or, for instance, expensive equipment as often as maybe the manufacturer suggests.
Yeah, that's definitely one aspect of it. The other bit is the sustainability side as well, right? Once you've got these sensors and they're all connected, you can start turning the lights down in rooms where you know they're not being occupied. You can start turning the air conditioning down in that room because it doesn't need to be as cool. And so, yeah, there's many applications that we can derive from these data streams as they're coming in. We can also use this, a lot of this information to start doing things like predictive maintenance and predictive analytics, and using machine learning to then predict how we design things in the future. So we make assumptions, and as Paul's mentioned a couple of times, we put parameters into the design and those are essentially assumptions on the parameters. Using these digital twins, we can then validate these parameters and adapt them for future designs.
We have a lot of questions, and I'm going to leap into those now. I can see the first one I think was probably for Wissam, which is, how is AR benefiting site operations, not design? And can you give examples?
So with that specific application, we need to use two specific tools, the 4D plus the augmented reality tool. Within the 4D model, you have your baseline schedule, you have your construction model linked together. What the AR tool is going to do is, you go to the site, you link the origin of where you are standing using the GPS system in your iPads, for example, to this 4D. And then you can physically compare what the 4D should have actually presented as a baseline completed item versus execution items which are not available yet for execution. Maybe you can just see a formwork, and basically the 4D model is telling you, based on this specific time, that column should have been done already. So this is how you can link between what has planned versus what has been done on site.
Okay, and actually, I'm going to leap to another question just to keep you here, actually, which is, somebody is asking, do you have to do laser scanning when you are looking to build some of the kind of the digital twin elements?
Well, the only reason that you scan it is that in case that information is not available in an accurate 3D form, basically you still have to scan it in order to convert it from what is, from nothing into a 3D environment. So laser scanning will be the right tool as your first step. And in that case, you have to not only just to scan, you have to incorporate the data in order to get that information out of it. In comparison to having a 3D drafter trying to overlay 2D drawings or taking measurements on site with pictures in order to replicate this into digital process. So yes, the laser scanning is an essential tool in case the detailed 3D model is not available for operation needs.
Okay. The next question, I think this is possibly Prakash, but if somebody else feels it's for them, please leap in. When developing smart cities, can you comment on big data transfer, gigabits of data, from data centers to the last mile and vice versa? How can legacy networks best be used, and what techniques can be used?
Yeah, so this is a big topic, I think, and actually a huge pain point in the industry at the moment. Not just for the stuff like the development of smart cities and the amount of information that's going to be flowing through there, but even laser scanning, right? So we do a lot of laser scanning, and transferring that laser scanning information even internally between our networks, and that is always a pain point. I think that we're with the sort of prevalence and the sort of move towards 5G technologies, that's going to help certainly in terms of speed and the amount of data that you can transfer efficiently and quickly. And then looking at other sort of innovations within the actual physical infrastructure, the built physical infrastructure. I know that there's a number of initiatives happening in the sort of fiber optic cables and things like that, to be able to allow for information to be transferred very, very quickly. And then I think that we're probably going to get to a stage where smart cities are going to have local data centers, rather than hosting them on data centers that are sitting all congregated in one part in country or in another country. Okay,
well, laser scanning is clearly a popular topic, because we have another question on that actually, which I'll open up to anyone. I don't want Wissam to feel he has to answer every single question. If no one else can, then please, Wissam, do. Which is, does the panel have use cases on laser scanning, including QA, QC checks, and what have they actually done using laser scanning?
Yeah, so I can take this one if you like. So I've done a number of things with laser scanning. So I think on a project that Wissam and I are both familiar with in Abu Dhabi, where we actually embedded into the contractor's contract that they've got to utilize laser scanning to verify the as-built. So there's two things that happened with that. Was one, we were able to compare the as-built, compare the laser scans to the 3D BIM models, and make sure that the things were within tolerance, right? So there's a certain tolerance that things have to be built at, and we were able to quickly be able to do that. One of the unintended consequences of this was initially what we were finding is that a lot of the MEP installation was completely wrong compared to the approved BIM models and approved designs. And as people started to realize we were doing this scanning, the future MEP suddenly started to be right. So the actual sort of notion or the perception that things were going to be checked at the level of detail that laser scan provides you automatically started improving the quality of the things going forward. So that's one aspect of it. And then utilizing laser scans to create 3D models of assets which don't exist, which don't have 3D models existing is another one, which is what I talked about, which was the project that we did in Saudi Arabia.
And Wissam, I think you were starting to answer that question or wanted to answer that as well.
Exactly. Like, I still have to go back to the QA/QC exercise. It's a great benefit to actually really understand, especially on a complex project. Most of our projects in the UAE are complicated projects. The level of accuracy that you can get from the laser scanning and compare it to a 100% accurate construction model, that level of information feeds a lot of databases. QA/QC team, the surveying team, the safety, the delivery, all of the construction team, the values and the automation from what the technology can give you from a tolerance perspective, it's really, really priceless. And this goes back to a previous topic you mentioned, what is the added value? This is where part of where added value will start to show. Better quality, less risk, and less rework on site. Even if there is a specific issue which happened, which we know construction, you have to just to mitigate with the on-site conditions. Laser scanning, you can just figure it out automatically, propose a solution, update your original 3D model, test it again with the overlay of your laser scanning, and here you go, a good solution to move to the site.
Picking up, if I may just quickly add on what Prakash said and also Wissam, I mean, laser scanner poses a huge advantage, especially, for example, in Europe, where there is a lot of retrofitting required and a lot of cultural heritage that basically there is no drawing. There is not even a 2D drawing. And actually, if you need to really move into sustainable smart cities in Europe and so on, and you actually need to build up first a model, and with a 3D laser scanner, you just quickly can do that. So there is a huge potential there too.
Thank you, Javier. So I think moving on, there is a question here which possibly Craig, if it's not you, Craig, then please pass it across. Is there a clear workflow to connect 4D and 5D, 4D or 5D models with a digital twin?
Yes, is the answer, I suppose. I mean, there's lots of different workflows. That's the point. And in fact, I was delivering something yesterday where we were talking specifically about this. The great thing with a number of different workflows, depending on what it is that you're trying to build into your digital twin, is that again, you maybe don't do them all at once. So what you do is you adopt a few workflows and you build those in, and then over time you then add another and then another technology, another way of working, another whatever it might be, 4D, 5D, and beyond. So absolutely, there's always a workflow of how you can build it in. But I think coming back to Paul's earlier comment, which is vitally important, is what is it you're trying to use this for? What is it you want to get out of this digital twin? What is it you want it to tell you? And we find that there's a lot of people looking at, they want everything. They want you to collect all the data and have everything adopted. And the reality is, half the time they don't need that. So it's really just about assessing at the start what it is that you want to achieve, and then build in as you go what you need. Because most times what we find is people don't need half of what they're actually requesting. And if they just sit down and think about what it is they're trying to achieve out of this digital twin, what analysis or decision making or whatever they're trying to achieve, then they can look at what workflows they need to build in. But there's always a way to take any workflow and build it into a digital twin. The other one is that the original kind of concept was that it was an operational digital twin, but now I think we've kind of come round to the thinking that you can have a design digital twin, you can have a construction digital twin, you can have an operational digital twin, and they all quite happily live together. So there's always a way to build in these workflows so that you have the information that you need at any point in the stage.
I have a question here, which I really like. This is a great question, whoever came up with this. When it comes to machine learning, what happens when the model predicts a certain outcome and human experience and expertise suggests something different? Anyone for that?
Well, basically, machine learning is acquiring all of those information from the human case studies and from the human type of feedback. So let's say that previous data history on a specific machine learning exercise provided you with a solution A. Based on a specific situations, the operator, based on his experience or her experience, will say this had to be operation B. So now you're feeding the machine learning with a new set of data, with a new set of information, so that in the future, machine learning will take into consideration that extra level of feedback and that extra level of an experience information. I believe, superseding whatever machine can do, that's need to be always an option. We don't want machines to run the whole project without the human interface. I believe more the artificial intelligence is to support the decision making rather than to reach a fully automated type of approach without a human interface. That's okay. Not sure Prakash will contradict or will approve, but
no, I completely agree with that. I think just relying on the output of a machine learning without using your wits and your experience is the wrong thing to do. We don't do that now, right? When we put stuff into a structural analysis software and the outcome comes out and tells us that this beam is going to work, when you actually know that it's failed in the past, you don't believe it. You'll go back and you'll go and check it. Then it's the same thing that will happen here, right? Is that the outcomes of this are going to give you choices and analyses in a much quicker time frame, right? They're going to give you lots of stuff, and I think it's going to be incumbent on us to then decide which ones we take and make a much more informed decision much more quickly. So machine learning and automation is going to augment what we do. I think there is a case of biases, right? And this, I think, alludes to that, is that these models are only as good as the information that's fed into them. And so if that data that's fed in has got inherent biases that's in them, or doesn't account for some of these outlier cases, then you're always going to get things that are incorrect. And it's something that's difficult to overcome. But being aware that these biases exist and that you're not always going to get the right answer out of these things is a way to deal with it, and then you can manage that accordingly.
And Paul, I see you're unmuted. Did you want to as well?
I just want to, what Wissam and Prakash have said there is absolutely right. I'd agree with everything they've just said. I would just urge a little bit of caution here. We use the term black box. We refer to tools like ETABS as being a black box. Machine learning is absolutely a black box. You have no visibility on what's going on in that box at all. It is we're completely and utterly blind to what it's doing. And it's totally reliant on the data that's fed in. So all the issues of bias that the gentleman have just referred to apply. So yeah, I would really urge incredibly powerful tools. They enable you to develop solutions really quickly, but a lot of caution there as to how they're interpreted and used. It still requires the professionals to be professionals, to evaluate the outcomes, to check the outcomes before they're taken forward.
I've got two questions here, which I'm going to combine because I think they're related. So will the cost of digitization, such as training and hardware, leave small businesses behind? And then a related question is, how can small companies best benefit from digital tools and automation? Does somebody want to take that? Craig?
I just want to say a quick comment on that. I mean, this is a common question, isn't it? How can small businesses, afford this? And it's interesting, but you need to start and look at not necessarily the cost, of the solution, but what's that going to give you? And usually it's going to give you some efficiency or some better way of working, and it's that efficiency that's the saving. And if that saving is then of time, which ultimately then is cost, then ultimately what you find is that the solution you're putting in place potentially will pay for itself in the efficiency and the time or cost savings that you're getting. It's kind of a misnomer to say, it costs so much, so I can't afford it. Actually, what you should be saying is, well, if I put this in place and I become so much more efficient, what money will that save me? And it might actually pay for your technology in the first place.
Totally agree with that. I mean, you can think of this is similar to the example like years ago, and of course I was not born then, when design offices were crap with drafters that were hand drawing the drawings of a building or of a project. And probably when AutoCAD came in place, it was not the small businesses who were running the testing or who were checking or assessing the benefits of that. But I can hardly imagine now that any design office, no matter how small it is, could think of hand drawing anything at all. So it's the same. Probably is for us big players who are making the pilot tests and who are showcasing and proving the benefits. Or even if for digital technology, there are lots and lots of small companies that are there putting their technology in place. But I think that every small company or a big company, they need to assess the benefit of the technology, and they need to really choose where it's going to be a benefit for them. It's not just that they need to go into a full package of digitalization and trying to run and quickly digitize everything at all, but they need to focus in what's the target cost of the technology, is what is the project, what is the cost of their company, and how they can overcome those initial target costs with the benefit that technology will bring in.
Can I just add a point there, perhaps? Yeah, I was just going to say, we talked a lot about technology, but actually at the heart of this is people, individuals. And if you can just find one or two passionate people in your business, people that get this and are enthusiastic about it, it can really make a huge, huge difference. They can build a lot of momentum, especially in a small business. And it doesn't have to be a transformation. We talk a lot about digital transformation and it sounds a bit scary. It can be done step by step. It can be incremental improvements. So it can be done project by project, script by script. And soon enough, you'll find you have a team of people that have this experience behind them, and your business is moving forward and it is transforming without actually that much investment. It just requires those key passionate people to drive it.
Yeah, I just want to make two quick points. I think what we're talking about here is value over cost, right? People are talking saying that it costs X, it costs Y, but actually what you want to be looking at is what's the value that it's going to bring to us, and is that going to make us more efficient? Is that going to help us win more work? Is that going to do a number of other things? And if that value is if that brings a value to you and to your business, then that's a cost that you would be wanting to incur. And so I think that we've definitely got to look at it from that perspective.
Thank you very much. The next in our webinar series will be looking at BIM, which is a subject that we actually touched on quite well today. But next time we'll go into it in much more detail. That's going to take place on Tuesday, the 7th of July at 2 p.m. UAE local time. The next edition of our Construction Technology Forum, which will be the third, will take place on the 23rd and 24th of February in 2021. For the first time, it's going to include the Construction Technology Awards, which are going to take place on the second day. A lot of work has gone into these awards, and we're really quite excited about them. The site is now open for entries, and you can see the address at the bottom of your screen. The awards celebrate best in class in a range of areas in digital construction, and we've put together a really stellar group of judges, and they are definitely looking forward to seeing your entries. With that, thank you to our panelists for your insights, really, really good insights. And thank you to you, the audience, for your time, interest, and questions.